Unit 3, Day 14, warm-up notes and a quiz checklist. A lot going on. But we're still talking about implicit differentiation. And these first two questions are the warm-up. So why don't you guys go ahead and pause the video, give these a try, and then when you're done and you have your answers, you can press play and I'll explain them and you can check your answers. All right, so let's look at number 1. If you're looking at this, you definitely have to do product rule here. So if we do, I'm just going to put it in parentheses. If we take the derivative of the first term, we'd get 3x squared. If we keep the y squared the same and then put a plus, now we're going to keep the x to the third to the same and take the derivative of y squared. So we get 2y, but you need a dy dx after it since it involved a y. All right, now minus 2x, derivative of that is just negative 2, equals, on the other side, derivative of 3y is 3, but you need a dy dx after it since it involved a y. All right, so we need to solve for dy dx. So we need to get all the dy dx terms on one side of the equation. So this term right here has a dy dx, and so does this one. All right, so I would, since that 3 dy dx is already on the right side of the equation by itself, I'd probably subtract this x to the third, 2y dy dx to the other side. X to the third, 2y dy dx to the other side. So these cancel. All right, and we are left with 3x squared y squared minus 2 equals, on the other side, our two terms, they both involve dy dx. I'm going to try to factor the dy dx out right now. I know I'm going to try to have to get dy dx by itself, so why not factor it out right now? In the first term, if we factor out the dy dx, we're left with a 3 minus, in the second term, we're left with x to the third times 2y. All right, and then we have to get dy dx by itself, so we're just going to have to divide by this big whole quantity, both sides. 3 minus x to the third times 2y. 3 minus x to the third times 2y. Those cancel, and that's what dy dx equals. And I guess I could write it a little bit nicer. Put the dy dx on the left, and on top we had 3x squared y squared minus 2. On the bottom, we had 3 minus, and I guess, with this term right here, you could put the 2 in front. Typically, constants are in front, so 2x to the third y, just to make it look a little bit nicer. You don't have to, all right? But that is your answer right there. If you chose to move the dy dx terms to the other side of the equation, you could have all the opposite numbers and still have the right answer. Say you had this is negative, this is positive, this is negative, this is positive. That would be correct as well. All right, so kind of two different ways to look at it, but you could have either answered the one I have on my screen right now or those signs right there. Both are correct. X equals x to the fourth. Find the derivative of the inverse of g prime. So remember, you have to know that there is a special formula there, all right? And it is 1 over the derivative of the inverse of 16. So you always have to do in the parentheses first. So we got to figure out, what's the inverse of 16. So I'm just going to kind of pull that off to the side. If we're trying to figure out what the inverse of 16 is, it's really g of what equals 16. We're looking for the x, and we're given the y. So we kind of need to solve for this here. I might even write that in there. We're looking for the x, all right, but we're given the y. Well, we know what g of x equals. G of x equals x to the fourth. What about if we just set x to the fourth equal to 16 and solve? All right, we're looking for what x we could plug in to get 16. Take the fourth root of both sides. You get x equals, think about what number can you multiply by itself 4 times to get to 16? Think it's 2. Think 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So it is 2. So that x value is 2, or otherwise, the inverse of 16 is 2. So we can keep going here. 1 over g prime. All right, we said the inverse of 16 equals 2. So we could put a 2 there. All right, now we got to find g prime of 2. All right, well, we have the function g. What if we find g prime first? If we just find the derivative, it's 4x to the third if we do the power rule. And then what about if we plug in 2? G prime of 2, 4 times 2 to the third. 2 to the third is 8, right? 2 times 2 is 4, times 2 is 8. So it's really 4 times 8, all right, or 32. So that's 32. So we would get our answer as 1 over 32 there. Of the tangent line, when you do that, you need the point and you need the slope. So it says find the equation of the tangent line to the relation x to the third, y to the third equals 3xy at the point 3/2, 3/2. All right, so we've definitely got the point. You know, for an equation of a tangent line, you need two things. All right, the point, we got that. All right, we just got to figure out what that slope is. And then we could do point slope form. All right, so this right here is our point. They gave it to us. So if we had to find the slope, we have to take the derivative of this. We have to do implicit differentiation. So step 1, all right, we have to find the derivative. So I'm just going to copy that. We've got x to the third plus y to the third equals 3xy. Think about, we're going to have to do product rule with that. So I'm going to put 3x times y there. All right, so if we do each term separately, if we take the derivative of this, we get 3x squared plus, if we take the derivative of y to the third, we get 3y squared, but you got to multiply by dy dx. All right, and on the right side, we need to do product rule. Again, these are our two quantities that we're multiplying together. So derivative of 3x is 3, keep the y the same, plus, let's keep the 3x, and derivative of y is just 1, but you'd have to multiply by a dy dx. All right, so we need to get dy dx by itself. All right, we need to solve for dy dx. So this term has a dy dx, so does this one. So we need to move all the terms with the dy dx's to one side of the equation, kind of by themselves, and everything else to the other side of the equation. And I might do this in my head, just pretty carefully, all right, just to kind of cut down on all the writing I have to do. So this 3y squared dy dx is going to stay on the left side of the equation. All right, this dy dx needs to go on the left side with it. So I'm going to subtract this to the other side of the equation. Not going to show my work, but if I move it to the other side, it's going to be negative 3x dy dx. All right, so I moved that. All right, next, this 3y is staying put, so it stays positive 3y. But this 3x squared needs to be moved to the other side, to the right side. So I'm going to subtract this 3x squared to the other side. All right, basically, if you move a term to the other side, it just switches signs. All right, so now we need to solve for dy dx. So on the left side, we need to factor out a dy dx out of each of these terms. So if we do that, take the dy dx out, we're left with 3y squared minus 3x equals 3y minus 3x squared. And then to get dy dx by itself, we just have to divide both sides by 3y squared minus 3x. Right, so these quantities cancel, and that is what your dy dx equals. This is your derivative. All right, but we got to go back to, wait, what did we have to find here? All right, it said find the equation of the tangent line. We needed point and we needed slope. All right, so the derivative helps you find slope. All right, it's the equation for it. But next, we need to actually plug in numbers. All right, so step 2, now that we have our derivative equation, this right here, all right, we got to plug in x's and y's from our point. All right, so step 2, we're going to plug the point into our derivative, dy dx. So if we do this, how you can kind of write it, we just found what dy dx equals. You can say I'm going to evaluate dy dx with the point 3/2, 3/2. All right, so that means, for our x, we're plugging in 3/2. For our y, we're plugging in 3/2. So I'm taking this equation and I'm going to substitute in 3/2 for all the x's and y's. So we'd have 3 times 3/2 minus 3 times 3/2 squared all over 3 times 3/2 squared minus 3 times 3/2. And maybe to make this a little bit easier to simplify, I'm going to make this a fraction, this a fraction. Might make it a tiny bit easier. All right, so if we carry out the math here, on the top we get 9/2 minus 3 squared is 9. We get 9/4 right here. So we get minus 3 over 1 times 9/4. On the bottom, we have 3 over 1 times 9/4 minus 9/2. So let's keep simplifying. We've got 9/2 minus 3 times 9 is 27, 27/4 all over 27/4 minus 9/2. All right, if we keep going, we should probably get a common denominator on top and bottom to make this a little bit easier. So I'd multiply this first fraction by 2 over 2. That'll get us a common denominator, and same thing here. All right, and since I'm kind of running out of room, I might just kind of use my eraser. But our first fraction, all right, this right here, if we multiply that together, we get 18/4. So I might just erase and call that 18/4. All right, and same thing happens on the bottom. If you multiply your two fractions together, 9 times 2 is 18, you get 18/4. All right, so if you actually subtract 18 minus 27, you get negative 9/4 on top, all over 9/4 on bottom. And you guys know anything over itself is 1, but there was a negative in there. So we get that that equals -1. And again, that was our slope, right? We took our derivative, we plugged in our point. That means our slope is -1. All right, so we said for an equation of a tangent line, you needed point. They gave us the point. All right, we needed the slope. We just found the slope. Last step is point slope form. I know I'm running out of room. Sorry about that. But think last step is point slope form. All right, so your y minus y1 is 3/2. Our slope is -1, x minus x1. That right there is our final answer, our equation of the tangent line. You guys should pause the video, give this problem a try. Once you get your answer, press play and I'll explain it and you can check to see if your answer is right. All right, so it says find the equation of the tangent line. So again, anytime you're finding the equation of the tangent line, you need the point and you need the slope. And they're saying find the equation of the tangent line to this equation at that point 3, -4. So awesome. They gave us the point. So check that off your list. We just have to find the slope. So step 1 is finding the derivative. So if we take our function x squared plus y squared equals 25, we need to find the derivative. So we get 2x plus 2y times dy dx equals 0. And to get dy dx by itself, you could subtract the 2x to the other side. You get 2y dy dx equals -2x. And to get dy dx by itself, divide both sides by 2y. And we get dy dx equals, the 2's cancel. You get -x over y is your derivative. All right, but again, we need the slope. So the derivative equation will help us get the slope. We just need to plug our point into it. So that's step 2. All right, we're going to take our derivative, dy dx, and we're going to evaluate it at our point 3, -4. So that means we're going to plug in 3 for the x's and -4 for the y's. All right, so our numerator was -x, so negative, and our x is 3. Our denominator is y, so our y is -4. So that's 3/4 is our slope. All right, so we could check that off our list. We have our point and our slope. So the very last thing is point slope form. So step 3, you guys know point slope form is y minus y1 equals m times x minus x1. We can use our point. So y minus a -4 equals our slope 3/4 x minus 3. Of course, you could clean this up and make this a plus right here. And that is your equation of the tangent line. Coordinates of the points where the function f of x has horizontal tangents. All right, so let's think about what that means. Horizontal tangents. All right, think about if you have a horizontal line, think about the slope. Slope of a horizontal line is 0. So, our slope is going to be 0. And, in calculus, slope is called derivative. So really, our derivative has to equal 0. And we have to find the x and the y where that happens. So how about if we take the derivative and set it equal to 0, and then we could solve for x. All right, so step 1, our function that we have, f of x, is 4x to the third minus 3x. All right, and if we take the derivative, we get 12x squared minus 3. All right, and we're going to set that equal to 0. So step 2, we said the derivative has to equal 0. All right, so we're going to do that. We just found our derivative is 12x squared minus 3. Set it equal to 0, and we can solve for x. So if we add 3 to both sides, we get 12x to the third equals 3. Could divide both sides by 12. So you get x to the third equals 1/4. All right, and if you... and I accidentally just made a tiny error. It was 12x squared, and then I changed it to the third power. Sorry about that. That should be 12x squared. So x squared equals 1/4. All right, and now you could take the square root of both sides. When you take the square root, you get 2 answers, plus or minus. Square root of 1 is 1, and square root of 4 is 2. So we get plus or minus 1/2. All right, so we're getting closer. They said find the x and y coordinates of the points. Well, we found the x's. Now we just have to find the y's. All right, so think carefully about this. What are we going to plug the x's into? You want to plug them back into the original function. We want to know the x's and y's on that original function that have horizontal tangents. All right, you do not want to plug them into your derivative. If you plug them into your derivative, you should get 0. All right, because that's the derivative gets you slope. Slope should be 0. All right, so just kind of think carefully about that. But we just need the y's now. So last step, step 3. All right, we are going to plug x equals plus or minus 1/2 into f of x to get the y values or the y coordinates. All right, so our f of x is 4x to the third minus 3x. All right, we got to probably plug them in separately. If we plug in positive 1/2, 4 times 1/2 to the third minus 3x. All right, think about that's 4 times 1/8. Oops. For this x, I should have plugged in a 1/2 too. Sorry about that. 1/2. All right, so minus 3/2. So this is really 4 over 1. We get 4/8, or it's 1/2 minus 3/2, which is negative 2 over 2, or negative 1. A lot of work right there. But think about the actual point. They wanted the x and y coordinates of the points. Well, when we plugged in an x of 1/2, we got a negative 1. So one of our points was 1/2 negative 1. All right. And let's try the other one of negative 1/2. So if we plug in f of negative 1/2, 4 times negative 1/2 to the third minus 3 times negative 1/2. Kind of a lot of the same math, maybe just some different signs. All right, we'd get 4 times negative 1/8 plus 3/2. So we'd really get negative 1/2 plus 3 halves. Negative 1 plus 3 is 2. 2 over 2, or 1. All right, so when we plugged in negative 1/2, we got 1. So that is our other point. Negative 1/2, 1. All right, these are the 2 points, or in other words, the x and the y coordinates of the points where this function has horizontal tangents. Stop after example 3. Says find the x and y coordinates of the points, so it could be 1 point, 2 points, or many points, where this relation has horizontal tangents. It's kind of the same thing as last time. Think horizontal tangents. All right, a horizontal tangent has a slope of 0, or in other words, that means the derivative, the derivative equals 0. But our derivative, if this is our relation, right here, all right, I think our derivative is going to be called dy dx. So that means dy dx has got to equal 0. So we should probably first find dy dx. Once we do, set it equal to 0 and start solving. All right, so step 1, let's find our derivative. So I'm just going to write out our original relation, x squared plus y squared minus 4x plus 7y equals 14. So if we take the derivative of that, we're going to get 2x plus 2y times dy dx minus 4 plus 7 dy dx equals 0. All right, we've got 2 terms that involve a dy dx. Let's keep those on the left side of the equation. Let's bring the other stuff to the right side. So subtract 2x to the other side. All right, we can add 4 to the other side. All right, so really what we're left with on the left side, all right, this stuff, we can factor the dy dx out. So what we're left with is 2y plus 7. And on the right side, negative 2x plus 4. And then to get dy dx by itself, divide both sides by 2y plus 7. Those cancel. That's what dy dx equals. All right, so we said our derivative has to equal 0. So next up, we got to take our derivative, all right, and set it equal to 0. So step 2, got to set dy dx equal to 0. That's kind of the game plan. So our dy dx is right here. So we got negative 2x plus 4 all over 2y plus 7. And we got to set that equal to 0. That seems kind of hard to solve since there's 2 variables, x and y. All right, but think about this 0. You could put it over 1, right? Still 0. You could put any number over 1 and it's still the same, right? What about if we cross multiplied? If we cross multiply, we get negative 2x plus 4 equals 0 times anything is 0. That just eliminated one of our variables, and now we could solve for x. So subtract 4 to the other side. You get negative 2x equals negative 4. Divide by negative 2, and you get x equals positive 2. All right, we're supposed to find the x and y coordinates of the points. Well, we found the x's. We have to find the y's now. All right, so think if we're finding points on that relation, we have to plug it back into the original equation, not the derivative. All right, so step 3, we're going to plug x equal 2 back into the original relation, and that should help us find our y's. All right, so our original relation, all right, x squared, I'm going to plug in 2 for x, so it's 2 squared plus y squared minus 4x, so 4 times 2, plus 7y equals 14. And we have to solve that. All right, so 2 squared is 4, so we get 4 plus y squared minus 8 plus 7y equals 14. All right, so we do have kind of some like terms here. We've got 4 and negative 8. So I'm going to bring down this y squared. Next, I'm going to bring down this plus 7y. And then I'm going to combine my like terms. 4 minus 8 is a negative 4 equals 14. And I think we should move the 14 over to the left side, so hopefully we can factor. So if we subtract this 14 to the other side, sorry, this is getting a little bit messy, we have y squared plus 7y minus 18 equals 0. And I think we can factor in order to solve that. So if we factor this, the y squared could be split up into y and y. Think numbers that multiply to 18, probably 9 and 2. All right, but we want them to add to positive 7. So how about plus 9 minus 2? And if we solve that, we get y equals negative 9 and y equals positive 2. All right, so think about our actual points that we got. All right, the x value was 2 for both of them, 2 comma negative 9. All right, and the other same x value was 2, but the other y value was 2, 2 comma 2. All right, those are the 2 points. Your final answer, if you were looking, it said find the x and y coordinates of the points where this relation has horizontal tangents. Those would be those 2 points. All right, we were able to only solve for one x value, but when we plugged that x value in, all right, we got 2 y values that went with it. So that meant there were actually 2 points and they just both have an x value of 2. All right, I hope you guys found this video helpful. If you have questions, definitely reach out to your teacher and ask. Otherwise, you guys can give the homework a try and have a great day.